Hello everyone, myself Sumit Waghchaure. I am studied at Ssjcop College of Pharmacy. I am studied in final year B Pharmacy. Today I am speak on a topic of gastroretentive drug delivery system, means GRDDS, under the guidance of Ajib successor. Abstract: solid oral drug delivery system is one of the most widely used drug delivery system in the world. It contains a predetermined quantity of a drug which is administered via oral route. It includes tablet, capsule, pellet, etc. The oral route is the main pathway used to deliver the drugs locally and systemically. Novel drug delivery system like gastroretentive drug delivery aims to improve drug bioavailability. Introduction: gastroretentive drug delivery system keeps the drug in the stomach for longer and releases it slowly. It used to improve the drug effectiveness and bioavailability. Prolonged gastric retention increases bioavailability, drug release duration, and reduce drug waste. It aims to release the drug in the upper gastrointestinal tract for local or systematic effects. Physiology of a stomach. The stomach can be anatomically divided into three regions: the fundus, body, and the antrum, also known as the pylorus. It can hold about 1.5 liters of food after a meal. The stomach stores, grinds, and moves food into the duodenum. The rhythm of stomach movement in cycle with alternating periods of activity and rest, known as a migrating motor complex, that is MMC. Here the diagram of human stomach. Factors affecting gastric retention time of the dosage form. First, density. The density of a dosage form should be less than that of the gastric contents, that is 1.004 gram per ml. Second, size. Dosage form having diameter of more than 7.5 mm have more than gastric residence time than that of 9.9 mm diameter dosage form. Third, age. People with age more than 70 have a significant longer GRT. Fourth, calorie content. High protein and high fat meals can increase GRT by 4 to 10 times. Fifth, frequency of feeding. Multiple successive meals can prolong GRT compared to a single meal due to the low frequency of the migrating motor complex MMC. Sixth, shape. Certain shapes like the tetrahedron remain in the stomach for a longer duration compared to the other devices of similar size. Types of GRDDS. First, floating GRDDS. In that subtypes, first effervescent and second non-effervescent. Second, bioadhesive GRDDS. Third, expandable GRDDS. Floating system. Floating drug delivery system are designed to float in the stomach. GRDDs remain floating, means buoyant in the stomach for a prolonged period of time. This system releases drug slowly and consistently in the stomach. After release of drug, the residual system is emptied from the stomach. Two types of FDDS. First, non-effervescent and second, effervescent. Here is the diagram of floating gastroretentive system. Effervescent GRDDs requires gas-generating agents such as sodium bicarbonate, salt, acidic ingredients such as citric acid, tartaric acid that form carbon dioxide gas in the presence of gastric fluid. It is a matrix type of system prepared using soluble polymers, example HPMC, and effervescent compounds, example sodium bicarbonate, tartaric acid, citric acid. When it comes in a contact with acidic gastric contents, carbon dioxide gas is liberated and gets entrapped in a swollen hydrocolloids, which provide buoyancy to dosage form. The buoyancy is for 8 to 10 hours. Non-effervescent GRDDs. It is also called hydrodynamically balanced system. No gas generating agent. Use high level means 75% of highly soluble and gel forming excipients means polymer. In this system, after swallowing, it swells due to imbibition of gastric fluid. Drug is mixed with the water-soluble gel-forming polymer that swells in a contact with gastric fluid after oral administration. It maintains a bulk density of less than 1. Ingredients often used in this system include hydroxypropyl methyl cellulose means HPMC, polyacrylate polymers, polyvinyl acetate, carbopol, agar, calcium chloride, polyethylene oxide, etc. Bioadhesive system. Bioadhesive drug delivery system are used as to enhance drug absorption in site-specific manner. It involves use of bioadhesive polymer that adhere to a epithelial surface in the stomach. Bioadhesive system adhere to gastric epithelial cells or mucus. Thus increase the gastric retention by increasing duration of contact between gastroretentive drug delivery system and biological membrane. Adhesive polymer include polycarbophil, carbopol, chitosan, sodium aluminate, etc. The longer residence time in the stomach can improve local action or systematic effect. Expandable system. Dosage forms are easily swallowed and reach in a larger size in the stomach due to swelling. Thus, the dosage form is retained in the stomach for a longer period of time. After drug release, their dimension get minimized and then eliminated from the stomach. The formulation is designed for a gastric retention and controlled delivery of a drug into the gastric cavity. A balance between the extent and duration of swelling is maintained by the degree of cross-linking between the polymeric chain. Here the diagram of expandable system. Evaluation parameters of GRDDS. A. In vitro evaluation. First, general test. Appearance, hardness, friability, drug content, weight variation, uniformity of content. Test on floating system. First, buoyancy lag time. It is determined the time taken by the dosage form to float on the top of the dissolution medium after it is placed in the medium. Second, floating time. The time for which the dosage form continuously float on the dissolution media is termed as a floating time. It is usually performed in a simulated gastric fluid maintained at 37 degrees Celsius. Third, test on a swelling system. Swelling index. After immersion of a dosage form into simulated gastric fluid at 37 degrees Celsius, the dosage form is removed out at a regular interval and dimensional changes are measured in the terms of increase in the tablet thickness diameter with the time. Second, water uptake study. It is done by the immersing the dosage form in a simulated gastric fluid at 37 degrees Celsius. After the stipulated time, the swollen tablets are weighed and water uptake is measured in the terms of percentage weight gain as given. Wu is equal to in bracket Wt minus Wo into 100 upon Wo. Wo is equal to initial weight of a tablet. Wt means weight of a tablet after time t. B. In vivo evaluation. Analysis of position of GRDDS in the GIT. Second, it involves an imaging techniques such as sigma scintigraphy and X-ray. Gastroscopy. Gastroscopy is used to inspect the visual effect of GRDDS in the stomach. Advantages and application of GRDDS. First, gastric residence time increase, hence drug absorption and viability improve. Second, drug releases in controlled manner for a prolonged period. Third, improve patient compliance via decreasing dosing frequency. Fourth, site-specific drug delivery to the stomach can be achieved. Fifth, enhance absorption of drug which solubilize only in the stomach. 6. Effective for local action in the upper GIT, example treatment of peptic ulcer. 7. Effective in the treatment of H. pylori infection. Limitation and disadvantages of GRDDS. High level of fluids in the stomach is required for maintaining buoyancy. Not feasible for drugs having solubility or stability problem in gastric fluid. Not applicable to the drugs that are irritating to gastric mucosa. Biodigestive system have a problem of high turnover rate of mucus and thick mucus layer. Conclusion. Gastroretentive drug delivery system means GRDDS can make the drug work better. They help when the drugs are hard to absorb, dissolve in acid and break down in alkali. To make GRDDS, you need to know how the stomach works and how the drug's form is affected by the different factors. These are some references which I collect the information. Here also some references. I like to thank Dr. Ssjcop sir, President of our college, Honorable Geeta Zondre ma'am, Secretary of our college, Dr. Nitin C. Moire sir, Principal of our college. For more informative videos, subscribe to our YouTube channel. Thank you.